In our last video, we saw how AI is changing manufacturing. We saw how generative AI is helping to build cooling channels for injection molding tooling, and how liquid neural networks are giving robots intuition so they don't crush parts. The brain is clearly getting smarter, but there's a catch. These robots we talked about, they're often bolted to the concrete. They live in flexible manufacturing cells or safety cages. They know exactly where the bolt is because the jig holds it there. Humanoids have a much harder job. They have to operate in free space. They navigate a world that wasn't built for them, stepping over cables, dodging people, and finding tools that aren't in the right drawer. But the way I see it, in 2025, humanoid robots are effectively having their Blackberry moment. They're impressive, but they're clunky. They fall over, they die in 4 hours. But the iPhone moment, the mass adoption, it's inevitable because of three converging drivers. First, the brain. 10 years ago, robots were dumb. They just follow the script. Now, thanks to LLMs, they can understand things like clean up that spill without needing to write a line of code. Second, the vision. We spent billions teaching cars like Waymo and Tesla to be able to self-drive. Now we're copying the same visual cortex into robots, but we still lack the data. That's why Tesla is paying people to wear motion capture suits while performing tasks, and 1X is doing teleoperation instead of autonomy. We're essentially brute forcing the learning process. But then there's the hardware, essentially the hardest part. We're trying to match human anatomy, which essentially has 1 million years of R&D behind it, with metal and motors. And as you're about to see, trying to recreate the human anatomy really makes you appreciate how amazing human biology is. When you build a humanoid, you have to worry about things like the Hertzian contact stress. You can't just basically take a washing machine motor and put it in a robot. If it jumps, the shock would snap a gearbox instantly. To solve this, many companies are moving to this planetary roller screw. Unlike a standard screw, it uses rollers that orbit the shaft. It creates 3 times the load capacity, allowing robots like Optimus to squat holding 200 pounds without snapping its knees. But there's another hurdle. Making these requires machining threads inside of a tiny nut with microscopic precision. It's so difficult that 60% of the global supply comes from just 2 companies in Switzerland. AI compute is growing at a rapid rate, but humanoids are effectively bottlenecked by Swiss grinding machines. Then there's the energy. This is when you realize how efficient you really are. We forget that humans run on superfuel. 1 kilogram of human body fat holds essentially 38 megajoules of energy. A kilogram of a lithium-ion battery holds only 0.8 megajoules. To carry the same amount of energy stored in just 1 kilogram of fat, a humanoid would need to carry effectively 47 kilograms, or 103 pounds, of batteries. The body is currently starving the brain. And speaking of the brain, the human's brain is effectively a supercomputer that runs on 20 watts, effectively the same as a dim light bulb. A humanoid's brain, like the NVIDIA chip these robots run on, burns up to 130 watts. That means a robot needs 6 times more energy than a human just to do basic things. But the biggest gap is in the movement itself. Engineers track what's called cost of transport. Because humans use tendons like springs to bounce forward, we get a high score of 0.2. But robots, they don't bounce. They use muscles through every step. Their score is often 0.7 to even up to 3. Effectively, it takes a robot 10 times this amount of energy just to move. They aren't just heavy, they're inefficient. But then you get into the anatomy. Do you ever look at how robots walk with their knees bent? Humans don't do that. We lock our knees and rest on our skeleton, and it costs almost 0 energy to do so. This is what's called passive dynamics. But robots, they can't lock their knees yet. They have to constantly pump energy just to stand up. Imagine doing a wall sit for 4 hours. That's how a robot feels all the time. So we spoke about a lot of the challenges, but what's actually working? There's a lot of players and some are doing better than others, but everybody has a slightly different approach. So if you ask who's winning, it really depends on what game you're playing. Consider agility robotics. People mock their digit robot because it doesn't really have a head and it has bird legs. But that's the point. They're not really building a full-on humanoid robot. They're effectively building a forklift with legs. It doesn't need to understand Shakespeare. It just needs to identify a tote and move it around. That's why they're one of the only ones with a verified commercial track record, and they've moved over 100,000 totes for GXO Logistics, who works for some really major players. Then there's Figure AI. They realize that most are not going to necessarily rebuild a factory for robots. You need to fit the robot into human-sized spaces. That's why they deployed Figure 2 in BMW Spartanburg plant. They worked an 11-month pilot, contributing to the production of over 30,000 cars. Their secret? They rented the brain. By partnering with OpenAI, they focused on the dexterity of the body, while OpenAI focused on the brain. Then there's Tesla. With their cars, they're playing the vertical game. When most companies spend $500 for a motor, Elon says, well, we can cast this motor and wind it in our own factory, probably for $50. This is the Model T strategy. It's incredibly hard to set up, but once you get it right, you have a cost advantage that nobody can catch up to. And beyond that, from what I see, they're getting a lot deeper into the nuances I'm not seeing with other companies. Really, the important things, like how the hand works. It seems like many other companies are really trying to paint a picture or really sell you the hype. And that's kind of misleading because you think that those robots can do those things, but not just yet. That being said, I'm sure they'll get there. It's going to take a lot of money. Then you have Unitree, which a lot of people talk about as being one of the most cost-effective humanoid robots. They're playing the horizontal game. They're buying a lot of off-the-shelf parts and integrating them to get down to a $16,000 price tag. But there's definitely a lot of trade-offs and capabilities. I mean, just look at the hands. While the Optimus 3 is edging on 22 degrees of freedom in the hand, the base Unitree G1 often lacks wrist rotation or complex fingers unless you pay for expensive upgrades. You're getting a robot that might be great for research, but it lacks the fine motor skills to perform tasks that most humans can. Another I've seen hyped quite a bit lately is this 1X Neo. They're playing the safety first game. You see that jump chute that the robot's in? It's not just for fashion. They're using tendon-driven actuators that are designed to be safe around children, so they say. Unlike the rigid industrial robots, the Neo is specifically designed to be inside the home. And their strategy is unique. Teleoperation first. They admit the AI isn't ready for full autonomy, so they sell it as effectively a remote control butler backed by human operators, slowly gathering the data to automate later. This data thing, it's a big challenge. Finally, Boston Dynamics. They realize that the human form might not necessarily be the best one when you're dealing with robots. Their new electric atlas reverses its joints to turn around. In a factory, efficiency beats biology. They traded looking human for being efficient. And Hyundai actually purchased them back in 2021, and they're currently being tested in Hyundai's Georgia plant, supporting production. So we gave a bunch of different examples, but where are we actually going to see these things? My perspective, I'd say first in the factory. The narrative is that humanoid robots are ready to replace all human tasks. The reality is they lack hands. A simple clamp can't pick up a drill or peel a sticker or feel if a thread is crossed. This matters because of the bin picking problem. Until a robot can reach into a messy bin and fish out a single bolt based on feel, we got a ways to go. It isn't a new species of worker. It's effectively a standard robotic arm on legs. That being said, we are seeing movement here. We're starting with structured tasks, but the iPhone moment only really happens if we can handle the chaos of the real world. Now, I just gotta say, this video might come across as me knocking folks or taking shots. The reality is, the folks that are doing this work are way smarter than I am and way more skilled, and it's really amazing. I just want people to understand that we have ways to go to get to the point where these robots are really doing everything that humans can. We can do many tasks in discrete ways, but to have one robot that can do everything, just similar to traditional large language models, to AGI and that sort of thing, we got a ways to go. But we're making tremendous strides, and it's a really exciting place. Hopefully, if nothing else, this just helps people to understand the challenges that folks need to overcome to actually make this happen. Finally, on another note, the home. And this is infinitely harder than self-driving cars. Think about if you had to operate a self-driving car on a road, but there's babies crawling around. Roads have rules, and living rooms, they have chaos, especially when you have a 3-year-old, which I could certainly attest to. That's why companies like 1X Neo are using Teleoperation. It's not really faking it, it's more like driving school for the robot. The home robot effectively starts as a remote-controlled butler, and only after millions of hours of training data, it can become autonomous. But before we invite them into our homes, we need to talk about the supply chain. Right now, the magnets, the electronics, and the motors largely come from overseas. If we don't own the manufacturing of the body and brain, we don't control the pace of innovation. The good news is the US might have a solution. The Replicator initiative is forcing American production of drones. By panic building factories for drone motors now, we're effectively building up the supply chain that these robots desperately need. And we need that domestic control because of the safety risk. Whistling Diesel just recently made a video destroying a humanoid robot and got millions of views. And although it was largely dramatized for the views, it's not really lost on me the idea of a 150-pound robot chasing around with a knife and that sort of thing. You know, if you think about it, if AI hallucinates in a spreadsheet, you just delete that line. But if a humanoid hallucinates or gets hacked, you have a really serious situation on your hands. So until we have really robust security standards, I don't really know about having a humanoid in my home. I think we'd be effectively inviting a level of digital intrusion that I don't think we're ready for. And from my experience, the US is generally a country that is more reactionary with its regulations, so don't expect the government to protect you from all these things. But either way, I'm still very excited. I just want us to think about this and be honest with ourselves about what's really going on, because not everybody really takes the time to go beyond just what we see on the surface level. And the reality is the industry is kind of full of smoke and mirrors at the moment. We aren't watching full autonomy yet. We're watching a very expensive puppet show. But just because the Blackberry was a little bit clunky doesn't mean it was a bad idea. It was just a little bit early, and it's no different here. I mean, Goldman Sachs predicts that this will be a $38 billion industry by 2035. So with all this energy and money going behind this, there's no doubt that this is gonna happen. But I don't really know what that's gonna look like exactly. I wonder what you guys think about that. I mean, are you excited about it? Are you scared about it? We need to be thinking about this stuff. We need to be smart about it, and we need to work together. So I think having these conversations, having real conversations, I hope that we can have more of them, and appreciate you guys watching this video, and I look forward to hearing your thoughts on this topic. Hopefully it's something we can cover more. So until next time, take care.